Well, thank you. It's lovely to be here and see familiar faces and some new ones too. And I'm going to talk about our adventures in the Public Library of Science with implementing what we refer to as our new Thesaurus. I'm going to spend a couple of slides on background because I don't know how many of you have ever heard of the Public Library of Science. It was founded in the year 2000 as an advocacy organisation. The thing that it was advocating was open access to the scientific literature. That is, scientific research to be published in a way that instead of libraries having to pay for it and giving restricted access, that authors would pay to have their articles published and everybody in the world could read them. And that's still the philosophy of the Public Library of Science. It discovered that the best way of making a start was to become a scientific publisher. So in 2003, PLOS Biology had its first issue published, followed in 2004 by Medicine, in 2005 by the community journals Computational Biology, Genetics and Pathogens, then in 2006 by PLOS ONE, who's a slightly different creature, I'll tell you about that in a moment, and in 2007 our most recent journal, PLOS Neglected Tropical Diseases. Okay, so just to give you an idea of scale, PLOS Biology, these numbers were done last Tuesday, which was the last day I was sane enough on this trip to be able to do them without making mistakes. 3,450 papers has been published by PLOS Biology, 2,626 by Medicine, 3,112 by Computational Biology. Genetics is quite a big one, 4,048. Pathogens, 3,639. PLOS ONE, 87,296. And Neglected Tropical Diseases, 2,444. Now, in case that whizzed by you, PLOS ONE has published 87,296 papers since 2006 and is our beautiful monster. Whereas the other journals are more traditional with respect to very selective about what they publish. PLOS ONE has an entirely different editorial strategy. If you do a good piece of science, it can be published in PLOS ONE. Everything is peer reviewed, everything is looked at, but if it's good, it can be published in PLOS ONE. And PLOS ONE is currently publishing 4,500, it gets about 4,500 submissions a month and publishes about 2,500. So now you're beginning to see why we're here, because you need to be able to provide access to, articles. So today I'm going to talk about our strategy, which has been to work with Access Innovations, building a good thesaurus that works for us, that is applied to the articles by machine-aided indexing. I'll talk about the initial implementation, integrating all of that into the workflow. I will talk about what we do for thesaurus maintenance. In the second half, I'll talk about content discovery, how having what we call our subject areas, that is the thesaurus terms, how that's helped people find their way through those over 100,000 articles to what they're looking for. And I'll close with a little bit about relative metrics, which is something special that we do. And I will say now that the work I'm going to be talking about is by several members of the product team that I'm a member of. And at the end, I'll tell you who they are and what they did, but this isn't all my work. You might be able to tell which bits are mine by how excited I get about it. But there you go. So our starting point, in 2011, we had what we referred to as the old taxonomy. There were only about 3,100 terms in it, and some ones that we really wanted to use, like apoptosis, programmed cell death, was simply absent. This was inflexible. It was inflexible in structure. So, for example, although we had the lymphatic system, we only had it as part of the immune system. We didn't have it as part of the circulatory system. So that made it difficult for people to use in the way they wanted to use it. It was housed in Editorial Manager, which was and still is the system we're using for our manuscript processing. And at the time, we hadn't figured out how to make any kind of update to it, so we were stuck. We were unhappy and we were stuck, which is a bad combination. And the way the articles were, the terms were associated with articles was by the authors choosing them. And authors have a variety of skills, and in doing this, some of them were more careful than others, some cared more than others, so it's a very patchy annotation. So we partnered with Access Innovation because we gave them the old taxonomy, 2,000 changes that were suggested. These were suggestions that came basically from within the organisation, staff editors, sometimes from academic editors, things that people wanted changed. We wanted to be able to use research and analysis methods as terms on our manuscripts for a variety of reasons, and one of those ways will be to do with reviewer matching in the future. And then we also gave some use cases. We wanted to be able to search on the basis of subject areas. We wanted people to find their way through our corpus on the basis of using the hierarchy. We wanted to be able to serve email alerts and RSS feeds, all those kinds of things. Access Innovations added their science, technology, engineering, medicine vocabulary, a lot of broader term, narrower term relationships, rules for machine-aided indexing, over 2,000 synonyms, and we worked backwards and forwards over the summer of 2012 to get the tier 1 and 2 terms into a good balance that we felt was going to work for everybody. And I'm reminded here of the book of Daniel, chapter 12, has got a verse in it that says, "And everyone will run to and forth, and knowledge will increase." And so that was a case of that. And in the end, we had this ISO 3919 compliant thesaurus. Just a few comparisons, went from 3,000 terms to over 10,000, from 0 synonyms to 3,291, and from 0 rules to going on to 15,000. The top level terms are shown here. I won't recite them all, but there were 10 of them, and they were broad areas which we felt that our users, because PLOS ONE publishes across the entire range of science, social science, our users would be able to recognize where to make a start. So we had the thesaurus, and then we had to make changes to the PLOS infrastructure that would enable us to use it. We instigated a devoted tax.plos.org, a taxonomy server. We put the thesaurus on it, and the data harmony application lives there. And we fed the entire corpus of articles to the taxonomy server, article by article, and we chose title, abstract, results, and methods as the initial run, and we chose to go with the top 8 terms. And that all went live on December the 18th or 19th, 1992, together, because it's always fun to do it this way, with an entire new article homepage, you know, and all different way of looking at it and everything. So we did that all at once. And this is what it looked like at the time. This is a paper from PLOS ONE, cytotoxicity of CD56 bright NK cells. In the one tab, the related content tab, and only the related content tab, there were 8 subject area terms. We could search for them in advanced search, and we could click on them. And that's where we were at the time. There were some teething troubles. And I've just chosen a couple of them to tell you about, because this is the kind of thing we do in these workshops, what things didn't work and what things did. Surprisingly, not all the articles had subject area terms. And it took a little while and quite a lot of work with the development team to pin down why that was. And it turned out to be to do with the initial implementation choice of title, abstract, results, and methods. And there was a condition there, because not all PLOS articles are research articles. Not all articles have a results, title, abstract, results, and methods. Some are discussion articles, some of them are reviews. So in the software, it was use title, abstract, results, and methods, unless you can't see an abstract. If you can't see an abstract, use the full text. And to cut a long story short, the software was seeing an abstract where there wasn't one for some articles. And yeah, we thought it was funny too after a little while. And so you could get the software to tell you, show me the abstract for this article, which I'm a human being looking at, doesn't have an abstract. And it would spit back this little bit of text, which would somehow be related to the article, but you couldn't find it in the article at all. But since it had seen the abstract, whatever this was, it had thought there was one. It had gone ahead and indexed the results and methods which weren't there and come up with no terms. And we did spend a lot of time, and we built a lot of relationships with the dev team trying to sort this out, but we could never get to the bottom of it. And we decided as a pragmatic solution to go on to indexing full text apart from references, and we've been there ever since, because we've never had a good reason to revisit it since then. And you can imagine at PLOS, the rate of increase of article publications is enormous, and so we're forever running. We're forever running to keep up. and there isn't that much, resource for extra development work. The second thing was that our taxonomy is polyhierarchical, and when we first put it through, it turned out only one path was being indexed for each article. And to show you what I mean, we're going to consider white blood cells. White blood cells are a narrower term of immune cells, and white blood cells are also a narrower term of blood cells. Immune cells map up to immunology, and immune cells also map back to animal cells. So there are 4 paths for white blood cells in our Thesaurus, but only one was being used in search. So that means, let's say that this path was being used in search. If you search for immune cells, you got all the articles that were hit with white blood cells, but you didn't get, I said that wrong. If you search for immune cells, you got all the white blood cell articles, but if you search for blood cells, you didn't, because not all of the paths were being used. Okay, so then we had to do a re-implementation, go through that with the dev team, go through testing and everything to figure out how we would get the full paths. So then we'd done all that, we'd done this work, we'd done this Thesaurus, we'd indexed the corpus, we'd put it on the website, fabulous. Then we have to do updates. New papers come into PLOS every day, and as they come in, they get indexed at the point that they come out of publication and into the web production platform. The MAI returns the terms and the hit frequencies. The new terms go into the search, Solar, the search index, and they appear contemporaneously with the articles going onto the website. This kind of update our IT and dev teams knew was going to come and were all happy about, and that was not difficult at all. We also, though, wanted to do updates for the Thesauri. This is because, we keep separate instances. So, for example, for the last 2 months of last year, Thesaurus number 6 from 2013 was on the production server, and I was working, and Callie was working on number 7. That's because of my nerves. We find that it's best to be able to test on a full corpus when you fiddle with the rules before you put it out. Otherwise, things can go disastrously wrong. And also, we didn't want, as we moved the Thesaurus forward, to have some articles indexed according to an old Thesaurus and some articles indexed according to a new. And to do a whole backfill of the whole past Thesaurus is quite a big deal. So the strategy was we would work at one for 6 weeks to 2 months and then just do the update all at once. And that's the way it's gone. So our cycle now is that we edit away at rules and the Thesaurus, the structure. We load it onto a test server and we test new terms, changed terms, deleted terms. We test rule changes, structural changes, and any implementation changes, such as when we got all paths going in. And we do these updates because there are new terms that we want to add. For example, memory T cells and monocots were 2. Sometimes a term needs to be changed. Report gene detection, I believe, was meant to be reporter gene detection. Sometimes we want to change a term, for example, webs into spider webs. And sometimes structural changes are desirable for one reason or another. And then there are rule changes where things are misindexed. Snails is either a mesodermal transcription factor or a mollusk. Fabrication is either a liar, somebody lying, deception, or building something. And I'll tell you about pumas in a minute. I don't need to go through this in detail, we use Thesaurus Master for making changes to the Thesaurus, changing broader terms and narrower terms, adding synonyms, adding notes, which makes a person feel very thorough. And then we make our changes in Maestro. So here we go, pumas. This is how the rule for pumas looked when we got the Thesaurus. And pumas in our Thesaurus were animals, vertebrates, cats, pumas. That was the kind of puma we had, which is the beautiful thing you can see on the right. However, PUMA is also an acronym for P53 upregulated modifier of apoptosis. And when I looked, it turned out there are 327 articles with P53 and apoptosis in. So I had to change the rule. This is my most recent funny. And I love being at something like this where I can tell people and you'll appreciate it. Most people think you're mad. So I changed the rule and I said text to match pumas. If it mentions and then used all these words that are to do with big cats, pumas, you know, things like that, panther, cougar, catamount, mountain cat, large mammal, feline, the genus name, and I thought that's great, so I ran it on my test server, and that looked really great. Except there were 18 hits, and there'd only been 16 when I did it the first time, and so then I found this paper, and this is just makes you laugh. Transcription analysis of murine macrophages infected with different, and the pumas, it's been indexed with pumas. I thought, oh no, I got it wrong. This paper must be about P53 and my rule's wrong or something. And there's only one mention of P53 in there, so that's not it. And the answer is that there's a strain of Toxoplasma whose variety name is cougar. But there's only one wrong for that reason now. So I just wanted to share that with you. How do we queue? How do we queue what we choose to work on? We see a lot of things ourselves. Ourselves is everyone in PLOS, the editors, the staff, people coming in also are academic editors and reviewers. Our readers tell us in email when they think that something's terribly egregious and might explain to us why. If it's Twitter, it just tends to be a complaint, you know, because they only get 140 to work with. Our editorial staff, and then I'll show you in a minute journal and save search alerts. We get feedback from that. And from flagged term reports. This was a nice feature that came in about halfway through last year. These little flags can be clicked red if someone thinks that the term has been inappropriately assigned, gets saved in the analytics, gets sent to me. Me and Callie prioritize them and use them as ways to find things to do. As we all know, there's a tension between strict and rigorous taxonomy and ontology construction and user utility. We live with that. We learned that abbreviations and synonyms are very, very powerful for getting good lists of hits for your machine-aided indexing. I still worry about whether you want to have T cells as well as memory T cells, obesity as well as childhood obesity, and usually we end up leaving both there. And at the moment we're working to the top 8, which sometimes means if it's a difficult rule, you settle for having it pushed down to 15 instead of eliminating it altogether. So that's just a balance. When we want to make a new export, we use the export facility of Thesaurus master and rules and build a new version. We do find the update reports extremely useful. They're very, very useful, and particularly for the Thesaurus update, for finding out when things happened and why, if we ever have to go back and revisit something. And we then use the admin feature to build our new project. That's not bad. So for the second half, I'm going to stop talking about how we maintain the Thesaurus and the subject area terms and turn to what changes it's made to our organisation and our user service since we have the subject area terms in place. As I said, all of our journals publish vigorously, and particularly PLOS ONE. That's the PLOS ONE homepage on the left-hand side there. Our current awareness tools that we've developed recently are journal alerts or electronic tables of contents, save searches and RSS feeds, and a hierarchy exploration, which is very nice, which we couldn't do before. This is my account. Anyone can sign up and get themselves an account. And if they have an account, they can set themselves up journal alerts. So these are the journals, plus biology, plus computational biology, plus genetics. You can choose to get your table of contents weekly or monthly. That's all fine, you just get them all. For PLOS ONE, you don't really want to get 2,500 titles in an email message monthly, or even a quarter of that weekly. So we now have this possibility of expanding and customizing your email alerts, and this is based on the subject areas. If you follow that link, you get to a screen like this where you can search for any term you're interested in, and this has got auto-complete on it, so if you do neuro, you get everything that's got neuro in it. The hits get displayed in a tree, and you can just navigate down the tree using the little clicky things. Select the terms you're interested in, save, and then then you get your emails weekly. This is the top of what your email looks like. The date range, it tells you which week we're talking about, it tells you which terms you're signed up for, and moving down the email you get your get the papers that might be of interest to you. These ones are the papers that have directly been indexed with trees in that week. These ones are ones that have been indexed with birches, so this is using the hierarchical structure to return the hits. This one has been indexed with olive trees. To move on to save search, you can use our advanced query to do any kind of query. In this example here, we've got olive trees or poplars. There are 70 hits for olive trees or poplars, and by using the search alert over on the other side, by clicking on that, you can set yourself up something that will be sent to you by email each week, and you can see a summary. In this case, this is Jonas's, not mine. Olive trees or poplars, RNAs, and transcription factors, which he only wanted to hear about monthly. Similarly, it's just ringing the changes here. If you'd prefer, rather than an email, to get your saved search by an RSS feed, you can click on the RSS logo and it gets delivered to your web browser like that. I know you can't read these, but each one of these is a title, then you get the abstract in that, which is really very nice. These are all things that couldn't have happened before we implemented the things we have with the subject areas. Hierarchy exploration. Clicking on the subject areas, now this is only available for PLOS ONE at the moment, but that isn't to say that we aren't thinking of ways that we might use similar for the other journals. If you click on that, a little thingy light box opens up, and you can select which of the top tier terms you want to look at. In this example, we're going to stick with ecology and environmental science. You can then go further into the ecology and environmental science section of the taxonomy. Community ecology, food web structure. You see now you're starting to get numbers at the end. That's telling you how many hits there are for that term. If you then click on that term, you go to the landing page for that taxonomy term, food web structure, showing results 1 to 13 of 147, and you can either look at them like that as a list, or you can make them look like the cover page. So in essence, this page is sort of a mini journal. It's the landing page for food web structure. You can bookmark that, you can come back to it in the future and see whatever else has come onto there. And that's a very nice feature.
On that page, how do you organize the listing of the articles?
You can sort by recent and popular.
Oh, so I see. Okay.
Those are your choices, and you can view by cover page or list. And I'd just like to close with a bit of discussion about relative metrics. PLOS has long held the belief that the impact factor is inadequate to express everything we would like to know about research publications, particularly because it focuses on the whole journal and not the articles that are in it. So PLOS has been a proponent, a strong proponent for a very long time of article level metrics. And that means for every article that we publish, we count how many page views, how many downloads, how many citations, how many Facebook likes, and there's a whole suite of things that go into the article level metrics. And when we had those, people realized that we could use them to compare for an article how it's doing compared to other articles that are published in a similar area. So the papers, so we group our articles by subject area, and we use tiers 1 and 2 for this. In a second grouping, we group papers by age. That's important for taking into account the fact that they've had longer or shorter time that these metrics could accumulate. And then we determine norms for the peer group. And we determine the average usage for a peer group and then compare that to an individual paper. Okay, and there's more information on that at that site if you want to know more. So this is an example. Here, this column here says HTML page views, and we collect these numbers from PLOS and also PubMed Central. This is the page views, and then this is PDF downloads. And the page view download ratio is a measure of how interested somebody is in the article, because the more interested you are in it, the more likely you are to download the PDF. So that fraction gives a count. of how the article's being used. And so for this paper, variability in frontotemporal brain structure, 13.21 of article views led to PDF downloads, and you can compare that number between different articles. The bottom part shows the usage. Now the blue part here is the peer group for this article. It's the reference set, and the dark blue is PLOS and the lighter blue is PubMed Central. And it shows that this article, consistently since when it was published, has been looked at more than its peer group has. So it's had more attention and had more reads. And the subject area that we're using to base that assessment on is radiology and imaging. By contrast, oops, I went the wrong way. By contrast, which developmental disorders get researched and why? It has actually 27.05% of article views leading to PDFs, but when you compare it to its peer group, it's running below the average use for its peer group. And we're looking at neuroscience here, but what you can do is if you want to have a look for another subject area that it may be more relevant to, in this case social sciences is one that's rather different, because it was about how the research gets done, maybe not so much about the neuroscience. Then you can change that, and in this case it doesn't actually make much difference. It's still being rather underused. And if you want to explore further, you can go to show the reference set, and that shows the group of papers against, specifically one at a time, against which it's been compared to come to these conclusions. And because it makes no sense to do relative metrics as soon as the paper's published, these set in at 3 months after the article's been published. So I was going to tell you about editorial workflow, but Helen's going to tell you about that later on. So I won't do that, which means I've actually undershot, so I've got plenty of time for questions. Or if anybody wants me to do another bit again slower, I'll be happy to do that too. Oh, but I haven't finished. Because this is really important. So I said there were several people who'd contributed to things. Jonas ran the taxonomy project before I was in post. So that means the early stages of this, working with Access Innovations, the very early stages where the tier ones are being chosen. Jonas was the contact person, and he says hello to everyone that knows him but can't be here this year, which is a bit disappointed about. Patrick and Sebastian are the ones who've worked on the browse down subject area on the PLOS ONE homepage, the red flag reports, the journal alerts, and the search alerts. They've done all that side of it. So that's down to Patrick and Sebastian. Jennifer and Martin are the article level metrics people. Callie Huss, who's sitting over there, works with me on editing the rule base and dealing with feedback from users and members of the community. And then John Chidaki is the head of our team. Thank you.